we are taking here let's say there is a 4-bar mechanism given to you. There is a 4-bar mechanism given to you like this. एक 4-bar mechanism आपको ऐसे दिया जाता है. Simple. This is a 4-bar mechanism. Okay. So for this 4-bar mechanism, you know very well. This is 4-bar mechanism and n equals to 4 and degree of freedom is 1. You know very well. Okay. Now its degree of freedom should remain same and we can replace one link in sliding pair. So first we are going to talk about the sliding pair. So for the sliding pair, a binary link can be replaced by a slider. So directly one link can be replaced by a slider. जैसे मान लो this is a link, number of link 1 2 3 4 1. So this fourth link we can replace by a slider. Okay, how? Look here, how we can replace it. This is the second link, this is the third link, and fourth link is replaced by a slider like this. Okay, and first link will be like this. First link is still fixed. First link is still fixed. So first, second, third, fourth and first. अभी इसका डिग्री ऑफ फ्रीडम चेक करो. इसका डिग्री ऑफ फ्रीडम इज स्टिल इक्वल टू 1. सेम डिग्री ऑफ फ्रीडम है. एंड व्हाट विल बी द नेम ऑफ दिस मैकेनिज्म? दिस इज कॉल्ड ऑफसेट. दिस इज कॉल्ड ऑफसेट slider crank mechanism. Why offset? When the line of stroke of the piston is away from the center of rotation of crank, away from the center of rotation of crank, it will be called offset. So this will be the value of offset. Okay, sometime this distance E is given to you and this is called offset distance. So इस mechanism का नाम क्या होगा? What will be the name of this mechanism? Offset slider crank mechanism. Clear? So fourth link you replaced by a slider directly. Okay. One more modification you can do. You can also replace the second link by slider. Okay. You can also replace the second link by slider. So if I replace the second link by slider in this way, that let's say like this. This is the third link. This is the third link and this is the fourth link. So fourth link has become slider now, and let's say this is the second link. Second link is also slider right now like this, and first is still fixed. So 1 2 3 4 and 1. So now again when you will check for this, again degree of freedom will be 1. Same degree of freedom. Now what will be the name of this mechanism? This mechanism will be called double slider crank mechanism. This will be double slider. Two slider are there. So this mechanism will be called double slider crank mechanism. Okay. Now, if they are moving in different direction. Let's say if you will move it like this, then you can feel here it will go up. Yes or no? So they are moving on different lines, but if you will put both these slider in a single line, if you will put both these slider in a single line like this, still the number of link pairs, whatever, everything is same. So here also the degree of freedom you can check. What will be the degree of freedom here? Again 1. Okay, but इधर होगा क्या? What will happen here? Let's say this is the input link, then this will be the output link, but there is no change in motion and no gain in motion. Then what is the purpose of this thing? You can replace this whole thing by a single body, yes or no? What is the need of having these 3 links? Because now there will be no relative motion between this and this. All these 3 will have same velocity, same acceleration, same displacement, everything will be same. So these 3 will look like a single link, yes or no? If there is no relative motion between any 2 body, they can be treated as single body, yes or no? Now it is not good thing to call it a mechanism. Getting my point or not? So here also, due to practically application or practical purpose is not solved. That's why it is not a mechanism, but theoretically it is a mechanism. Getting point or not? Theoretically it is mechanism. You can check n is equal to how much? N is equal to how much? N, 4. How many lower pair? 1, 2, 2 revolutory plus 2 prismatic. Okay, so total 4. How many higher? 0. So now you can check the degree of freedom. 3 n minus 1 minus 2 L minus H, like this, and no degree of redundancy. So here degree of freedom will be 9 minus 8 equals to 1. So theoretically it is a mechanism, yes or no? Mechanism by theory. It is a mechanism by theory, but practically it is having no extra use. Okay, it can be replaced by a single body. Okay, so same input output you will get like this. बात समझ आई कि नहीं आई? So still the theory is not complete. It will be invalid in many cases. Are you getting my point? जिसको समझ आई ये बात कमेंट में लिखो जय हिंद. Okay, Abdul, you can go, no issue. Those who got this point, write down Jai Hind. Still this theory is not complete. Okay, theoretically it is saying this is a mechanism, but practically this is of no use. Okay, practically it is of no use. You can replace all the 3 links, 2 slider and 1 intermediate link, by single link. Okay, very good. So theory is in developing phase. It is not still fully developed. Okay. Now let's talk about the second, spring. How we can convert a spring into other link or compare into other link. So for the spring, look here, 2 binary links with a turning pair, 2 link and a pair can be replaced by a spring. So second example we are taking now. Let's say one link is this, okay, and another link is this, okay, and another link is this. These are single link. connection, connection, and one more connection, these. Now here it is having two links like this, like this. Okay, so you can see that if we want to calculate the degree of freedom of this mechanism, find कर सकते हैं कि नहीं? Find degree of freedom of this mechanism. Let's say this is fixed, one link will be fixed. Find its degree of freedom. Find करो. First of all, number of link. 1, 2, 3, 4, 5, 6. 6 होंगे. Now, number of lower pairs. 1, 2, 3, 4, 5, 6, 7. 7 है ना. Number of higher pair 0. ठीक. Find the degree of freedom. And there is no redundant also, so no need to write. So simply 15 minus 14 equal to 1. So it is a mechanism, yes or no? It is a mechanism. Now we have to convert this mechanism into an equivalent mechanism by adding the spring. So look here, these two link 5th and 6th with a turning pair, two link and one turning pair. These three will be converted into a spring. These three will be converted into a spring. Okay, so here I will replace those two links by a single spring like this. By a single spring like this. So spring is your resistant link. It is not rigid link. Okay, it is not rigid link. Got the point or not? Now when you will give particular input to any link, then same degree of freedom 1 it will follow, and all other link will follow particular motion. Okay, what is the use of it? If एग्जाम में आपको ये देते हैं, if they will give you this problem in exam, you will solve easily, yes or no? No problem will be there. But if they give you in the exam problem like this, what you will do beta? You will replace this spring by two link and one turning pair like this. Then you can find its degree of freedom, yes or no? There is no rule, no theory still developed how to select this link spring and how this spring will behave. So no theory is there for the spring. बात समझ आई? Got the point or not? अगर आपको ये प्रॉब्लम they will give you in exam, first you will convert into this, then you can find the degree of freedom, because this is the equivalent mechanism, so the degree of freedom will remain same. बात समझ में आई? Got the point or not? Very good. So write down here, if in exam you got this, you will convert like this. Okay, because this can be converted like this. So these are convertible, these are equivalent mechanism. So we know the degree of freedom for the left mechanism. So for damn sure this will also have degree of freedom 1. क्लियर हुई बात? जैन लिख दो फटाफट.